Hello, my name is Chance Hattrick, and this is my 3.3 DER project, the traffic light. Now, as you can see right now, it's incrementally going from the red to the yellow to the green light as it would with a traffic light. And another extension I added is that you should have cars when you have a traffic light. So I have these LEDs here mimicking a car. So on yellow, it will flash twice. And then on green, you can see the car is moving like so. And then when it turns red, the cars will stop. So you may be wondering why I have this piece of paper on top, and that's just because you wouldn't be able to see anything otherwise. So let's take a look at the circuit. Now that we don't need this. So the circuit is made up of three key parts: the Arduino, the traffic light PCB, and the LEDs. The LEDs and the traffic light work in a very similar way. The LEDs are simply three LEDs that share a ground pin. So you only need to control the anode pin. And it's the same thing for the car LEDs. You just need to control the anode pin. What is really interesting is how this works, because we're not using the typical high-level programming language typically used in the Arduino IDE. What we're using is assembly language. Maybe wondering, Chance, there's nothing in this function. How is it possible for the circuit to work if we don't have anything in the code file? Well, that's because all of our code is stored in this .s file, which lets us run assembly language. Assembly is the midpoint between the high-level code that most people are used to and the machine language that is used by the microprocessor. And what that does is it has these preconceived functions that either store bits, perform some form of arithmetic, or store something to a register. Essentially, very similar to how our chump worked. So, in this function, we control the states of 7 LEDs. We first call the setup, which allows us to set all the anode pins to output. And then once we finish that, we return back to the main function, where we jump to the loop function. And what the jump means is that we're not returning back to the main function anymore. So then we go to loop. We set R17 to the value of num, R17 being a register 17, and num being the value 2. Now we call the red function, which turns on the red LED, and then we call the car stop function, which turns on all 4 of the blue LEDs. We then delay 4 seconds, which uses the delay 1 second 4 times. And what delay 1 second does is it fills the registers 18, 19, and 20 with these values, and then essentially decrements them a number of times so that you waste enough clock ticks for 1 second to pass. Once it's done delaying for 4 seconds, it goes to the yellow function, which turns on the yellow LED, and then it calls the car flash function 2 times. And the car flash does the same thing as the car stop, except it flashes the LEDs. So you see it going, you clear the bits in these ports 1 through 4, which are A0 to A3, and then you call a delay so that you can see that it has disappeared, and then you set the bits to high using the SBI function, so that's A0 to A3, and then you delay for 1 second before returning back to the function. And that is repeated twice. And then we use a delay 1 second before turning on the green LED. And what the green LED does is that it turns on the green LED. And the rcall car move turns on each of the LEDs individually rather than together. And that does it by loading the bit of 4 to R16 and then setting R16, which is 4, or to on, which turns on A3. And so that's how this code works.